How are you, everybody who is watching this fantastic video? My name is Sir Olenjolai. I'm very happy to have you today and have a very good news for you to benefit your present and future life. So stay tuned, and you have made a good choice. You are warmly welcome into this fantastic moment of learning the beauty of higher engineering and scientific mathematics. I come from Tanzania, eastern of the African country, and so I'm very happy to have you today. Once again, I would like to take this opportunity to welcome you into one of our online institutions at Online Undergraduate Polytechnic Institute of Tanzania, square bracket OLENJOLAIM. And I would like to welcome also into one of our YouTube channels that's called Online Undergraduate Institute of Tanzania, square bracket OLENJOLAIM. Right? So, well, this is a kind of the fantastic institutions because really it is supplementing what actual students used to learn formally in their institutions or colleges or universities in Tanzania and even in other African countries and even in other countries across or around the world. However, that our focus is, we are focusing on the engineering institution, engineering university and colleges, but also with what we are also focusing on the scientific institutions, colleges, and universities. So if that's the case, that I would like just to remind you, because we have problem that we are solving, a national problem and international problem, and have also then we lay out the solutions of solving that problem. We have also a vision in Online Undergraduate Polytechnic Institute of Tanzania, square bracket Olenjolai. So we have also main objective in Online Undergraduate Polytechnic Institute of Tanzania. We have also specific objectives. We have also a mission. We have also achievements, and the way that we can measure our achievements in a year. So you have so many information that we wanted to share, or we strongly desire to share with our students. But today I want just to share one thing, that the vision. What visions we have in Online Undergraduate Polytechnic Institute of Tanzania. So it's an assignment that has been given by God Himself to teach and train some group of students who will be ready to take the classroom, to extract knowledge and wisdom from their formal or informal classroom instructions, and combining with extracted knowledge from the Word of God that reads in the Holy Bible in order to solve real life problems. Our main objective in Online Undergraduate Polytechnic Institute of Tanzania is to see our continuing students and even our graduate students actual solving real life problems. That's our main objective, that's our strong desire, that's our destination, that's what we are expecting to harvest in this great work that we are doing, which actually we are toiling day and night in order to make sure that these things gonna be all right, and nothing is going to miss, or nothing is going to be done and below the level. So that's the vision that we have. We have also so many specific objectives. For example, to help undergraduate students to master the modules or courses in higher engineering and scientific mathematics. That's one of our specific objectives. Also, to let you know, it means that to restore your lost love in mathematics. Also, it's one of our specific objectives. Also, to make sure that you master, not even just you master. It means that if you have never loved the subject of mathematics, you can start from today. You are not late. Also, that's one of our specific objectives. But also to prepare you for your continuous assessment, for your testing, for your assignment, for quizzes, class quizzes, prepare for the final exams. All of those are our specific objectives. So we are doing great things, but remember that everything that we are teaching in Online Undergraduate Polytechnic Institute of Tanzania, square bracket OLENJOLAIM, will never cancel the instructions that you are learning in classroom. I recommend and I ask you to attend your regular session and then take these contents as the supplement to make sure that your journey becomes smooth as long as you navigate with engineering education. So we have so many departments, but one of the departments is called the High Engineering and Scientific Mathematics. We have another department of the Kingdoms of Heaven, or it's called Kingdoms of Heavens, that where we teach the knowledge of the Word of God. Also, we have some 12 modules. We are teaching 12 modules or 12 courses. One of the modules of the course is called the calculus. In some of the institutions or some of the universities, they call these modules engineering mathematics 1, or they call it possibly that engineering mathematics too. So it depends. But the issue is just to remember calculus. For example, at University of Dar es Salaam, they have equivalent course with this of calculus that we are covering according to the NACTE, with the focus of the competence-based. It's called IBESCI. It's called matrices and basic calculus. So in some of the universities, for example, State University of Zanzibar, African University of Tanzania, University of Dar es Salaam, they just call it basic calculus. So the name might be a little bit different in university of this contents of this stuff, but the issue focus on the content, right? Focus on the content. You might find the name is quite different from what is called calculus, but you find the contents are the same because mathematics is universal. So this is in all institutions that under NACTE, National Council for Technical Education, this module is covered in the first semester of the first year. I'm teaching you the first chapter, Theory of Limit. The subtopic which I'm teaching is called Continuity and Discontinuity of the Function. And this is lecture 10, the last lecture for the topic of the theory of the limit. Okay, so problem solving of what? Continuity and discontinuity of the function. That's the title, that's the subject of the day. Let me do the quick review. So remember that this is competence, we are focused on the competence based and we are preparing the competence engineers. Let me do the quick review, ladies and gentlemen. Quick review of what? Of lecture 9. In lecture 9, we have covered so many concepts, but let me remind you a few of them that we need. First of all, we define the meaning of what? Of continuity, means definition of continuity of what? Continuity of the function. Okay? Secondly, then we define it mathematically. We say that if f of x is continuous, right? If f of x is continuous, because we say that we have continuity of the function at the point and continuity of the function at the interval. If f of x is continuous at what? At x is equal to a, for instance, then we say that limit as x approaches to a of a function f of x, this will be equal to the value of the function at that point. And then I told you about sided or one-sided continuity of the function. Then you say that you can find the limit of the function as x approaches to a. This is equal to the f of a. So this is equal to left-sided continuity. Then for the right-sided continuity, we say that limit as x approaches to a positive of f of x should be equal to f of a. But also we talked about discontinuity. For the case of the discontinuity, we say that if the function f of x is discontinuous, means limit as x approaches to a of f of x, this is not equal to what? To f of a at the case. So we have covered so many. It is a lecture of more than 90 minutes. So we have to go through because I laid out the foundations and I built the walls there. So today I'm going to put the roofing in order for us to dwell in the house that's called continuity and discontinuity. So with today's lecture, we are dealing with sort of continuity on an interval. Okay? Continuity of the function, because this was the second concept, continuity of the function. Continuity of the function. Okay, continuity of the function on an interval. Continuity of the function on an interval. On an interval. So simply, let me write one sentence and then we go to, we learn this continuity of the function on an interval by using questions. So just have one sentence and then we go to solve 3 important problems. So this is a relevant sentence. We can study the continuity. We can study the continuity and discontinuity You can start the continuity and discontinuity of the function of the function f on an interval negative c less than or equal to x less than or equal to c, or negative b less than or equal to x less than or equal to b. So you can study the continuity, you can study the continuity and the discontinuity of the function on an interval of, let's say, negative c less than or equal to x less than or equal to c, or negative b less than or equal to x less than or equal to b, or negative a less than x less than or equal to positive a, or you can find that we can have maybe c1, or we have a less than or equal to x less than b, etc., etc. So you have different cases. So afterward, we ended with the example 21 in the lecture 9. So ladies and gentlemen, allow me to write the example 22 for you. Okay, example 22, and this is, you can refer some past papers of DIT final exam or end of the exam. Determine the discontinuity and the continuity of the function f on an interval. Excuse me. Determine the discontinuities if any of the following. Function. F of x is equal to twice x plus 1, x less than or equal to 0, then 1, then 0, okay, and this is x squared plus 1, x greater than 1. So 2x plus 1, x less than or equal to 0. F of x is equal to 1, 0 less than or equal to x less than or equal to 1. X squared plus 1, x greater than 1. Okay, so that's the question. So you can pause the video because I told you for the composite function which contains how many functions? 2 functions, right? It just contains 2 sub-functions. I told you in example 21. So you just use the same concept. However, that one, you have been asked about decided continuity. That's not the case. I know that you understood more than what I asked you, or more the questions asked there, because you are the excellent mathematicians. You have to compose at least 3 questions surrounding 1 question in your hand. All right? So determine the discontinuities. So the questions asked here determine the discontinuities if any of the following function. This is the composite function, and this composite function comprises 3 sub-functions. The first one, example 21, comprises how many sub-functions? 2. And the composite functions, we have the function, its domain, function, domain, function, domain, function, corresponding domain. So let me teach you how you can solve. Again, right now, when you are watching this program and you find this helpful for you, it's probably actually it is giving you essential material and you understand what I'm teaching you. I ask you, please, you can spend 30 seconds, you can spend just less than 20 seconds just to click this button, subscribe, and then a bell is going to appear of this form here. Then you click this bell, you find many options, but for you, just you have to choose all. So you just click here, see your cursor, then you come, you click on the bell, then when you click the bells, it will give you 3 options, all, personalized, and none. So just click all. Then once we add any new video that we are going to do that business every day, at least 1 video in a day, you'll be the first one to get notification from the YouTube community. All right? Okay. So if this is the case, you say that, okay, solution. So now we are going to deal with the entire functions, not the one-sided. So we'll be following number of steps. So don't forget to subscribe. And you cannot subscribe without having an email. So make sure that you send in with your email. Okay, and don't forget to share also this content with other students. The first stage. The first stage of this, there's a different way that we can solve, right? But the first stage, we say that recall the formula, the general formula of what? Of continuity of the function. As I said, I've never taught this concept or the entire topic of zero of limit in this level of the function, right? I taught at 20 x is equal to a. We say that the limit, so just clearly define the limits as x approaches to a of f of x, this should be equal for the function to be continuous with f of a. So suppose that this is equation 1. Otherwise, it's not watching, it's continuous. So you can deal with the right hand side or the left hand side. So let us consider the left hand side first and come back to the right hand side. Second step, we say that consider left hand side of equation 1 above. Okay? So to consider, we say that we have to find limit. So limit as x approaches to a of f of x, this should be equal to limit as x approaches to a, and then of 40 above of f of x, and this also should be equal to the limit as x approaches to 40 approaches to a positive f of x. That the general definitions of 40 of the limit. So, if you examine our question, what are the values of x? We have so many values of x, but the boundaries are 0 and 1. Boundary here are 0 and 1. Because these are the values of x less than or equal to 0. These are the values that greater than x, x are greater than 0 or less than or equal to 1. These are the values greater than what? 1. So we have so many values, but we know the boundaries. So to know that what A should we use and where can we use, we have to go to the third step. So it says that choose the values of the point that you want to test, of 40, the values of points. These points you call them A, right? That 30 define what? That defines fx. Right? So we say that how do you choose values of a from this composite function? That's a good question. It means that we say that we choose values of A that contains either less than or equal or greater than or equal. Operator contains either less than or equal or greater than or equal operators. So for this case, we say that we have less than or equal, so this is the one value of x is equal to a. This also the same, and this is less than or equal to 1. So another value is what is 1. So this one is exclusive in case of the value of the x. So we say that if for that case now a1 is equal to what? Is equal to 0. And hence a2 is equal to 1. So we have to check this continuity. We have 2 points. So here, mean that we have what? 2 points. 1 point is what? X is equal to 0. Another point is what? X is equal to 1. So you have to test it for each point. Alright? That's a very important piece of information. So it means that we got the first step. Say that let us find or let us deal with what? So we say that find or check discontinuity of what? Of the given function f of x at x, let's say is equal to a is equal to 0. So to check the discontinuity, we have to find what? Limit as x approaches to 0 now of the function. So we come back. Where do you have x less than or equal to 0? This is the value where x is less than or equal to 0. The value that where x is less than 0, it's not equal to 0. So when you find the limits of the function as x approaches to 0 from left-hand side, we have to use this function, as I told you. So you have to use that function. So it is what? Plus x plus 1. So if you substitute 2, you find that you have 2 times what? Times 0 plus 1. Answer is 1. Right? That the limits of 40 left-hand side. So again, according to our second formula, we have to find limit as x approaches to 0 positive of what function? So this is the limit of right-hand side when x greater than 0, but when we approach 0 from right-hand side. So this is the function, because here we have x greater than 0, but x greater than or equal to 0, and here x less than or equal to what? To 1. So the exactly value here, which we take consideration, which we need this in domain x greater than 0. So the function is 1. So the function is what? Is 1. So therefore the limit for this case is what? Is 1. Okay? Okay. So then, because we need to substitute these values, so you can say that, suppose that this guy is equation 2, and this guy is what? Equation 3. So to check if the limits of the function exist, suppose that this is equation 2, and suppose that this is equation 3, and this is equation 4. Okay, question 3, question 4. So, here it is. The fifth step. The fifth step, we can say that substitute equation 3 and the equation 4 into equation 2. So to substitute it there, we have limits of left-hand side. So limits of left-hand side for this case, it's 1. Then we have limits of right-hand side, it's 1. And then that is equal to what? Limit as x approaches to 0 or 40 f of x. So the limit of the function exists. So limits of the function f of x are as x approaches to 0 exist. So this limit is equal to what? 1. Okay? So we've been working for the left-hand side of equation 1. So we go, in case you have any question, don't hesitate to ask in the comment section. And also give us comment in the comment section, please, if you've understood. The sixth step, consider right hand side of what? Of equation 1. Right? Because the right hand side, you have to find out f of a. F of a, but this case you say that f of a1, which is equal to f of 0. Okay? F of 0. So to get f of f, remember that I told you, to find the value of f of a, in the composite function, we are going to use either the function which is domain has operator of less than or equal, or the function which is domains have operator of greater than or equal. Otherwise, you won't get any results. Alright? So I want to leave this question part. So the point where you have less than or equal to 0, it is, for this one, is actually one of the points, so we are interested in this. So you say that in our f of x is equal to 0, for this case, as I say that we are going to use the first function, plus x plus 1. So that's f of x itself. Okay? F of x is equal to twice x plus 1. So we have to look at equal to 0, so 2 times 0 plus 1 is equal to 1. So f of x is equal to 0, x is equal to 1, to make it. Here we ended question 4, this is question 5, this is question 6. Then the next step. Substitute. Substitute question 1 to question 5. And the substitute. Question 5 and what in the in question 6. into question 1. Okay, into question 1. So substitute into question 1. Then we say that on left hand side we have 1, on right hand side we have 1. Then what happens there? If limit of the function is equal to value or is equal to value of the function at that point, then we say the function is continuous at that point x is equal to 0. Okay, so we say that the function f of x is continuous, it's not discontinuous. It's continuous at what? X is equal to 0. Again, we have another plenty where we say x is equal to a2 is equal to 1. So I have to check also there whether the function is continuous or discontinuous. So we do remember that in question 1, so we say that we have to go for the series import the 8 step. We have chosen the value of a, that's equal to 1, so that's not a great problem. I have to find limit. How to find what limit. So you have to find limit of what? Of the function. So to find limit of the function, we say that, well, the function at what? At x is equal to 1. So listen carefully. So to find limit, we say as x approaches to 1 bar of f of x, this is equal to limit as x approaches to 1 bar of what? F of x. So 1 bar, it means that we are dealing with the function which domain is x less than or equal to 1. What is that function? This one. Because here it is x less than or equal to 1. So our function there is 1. So then if it's 1, this is the constant. So the answer of the limits of the function, or as x approaches to negative, is equal to 0. X is equal to left side is equal to 0. Is equal to 1, excuse me, is equal to 1. Then we have to find that limit of left hand side, guys, which is 1 positive. I told you this is stuff in previous session. So in case you didn't understand, ask. Of what of the function f of x. So in this case, what do you say that? Say okay. So if x approaches towards what? 1. So here we need the value of x that is greater than what? Greater than 1. Greater than what? Greater than 1. So limit as x approaches to 1 positive for f of x, which yes of f of x, f of x, we say as x greater than 1, this second steady composite function, it's x squared, because in x squared plus 1, x is greater than 1. So this is x squared plus 1. X squared plus 1. Alright? So if you find the limits near to this to 1 from the right hand side, then you end up having 2. Alright? 2. So from there, we say that find the limits of the functions at x is equal to 1. So the ninth step, say that check if the limit exists. For the limits to exist, we say that so we say that for the limit to exist, it means the limits of left hand side should be equal to the limits of 40 of the right hand side. So we say that as limit as x approaches to a bar of f of x, this should be equal to the limits as x approaches to a positive f of x. Alright, f of x. So if that the case, you say that this will be equal to L. Let us check. Limit of left hand side, that's as a bar is equal to 1. Limit of right hand side as x approaches to 1 positive. This one is equal to what? Is equal to 2. Is 1 equal to 2? No. Is 1 equal to 2? No. So because the limit of left hand side is not equal to the limit of right hand side, then here we say that the limit does not exist. So if the limits of the function does not exist, then we expect that to be one of the array type of what of continuity. So you say that, therefore, the limit of the function f of x does not, where the function does not exist. Does not exist. Therefore, the function f of x is discontinuous. Discontinuous at x is equal to 1. So at least you discovered one of the discontinuity. That's the end of that question. So you see that how hard you have to work to make things work. Okay? So this is the way that how hard you have to work to make things work. So the limit of f of x does not exist. Therefore, the function f of x is discontinuous at x is equal to 1. Then she had 2 points, x is equal to 0, x is equal to 1 to test. That's the end of the questions that you've been solving for. Is it interesting? Did you understand? Tell me in the comment sections so myself to become rejoiced, to become happy, right? Because I'm always very happy if all my students understand what I'm teaching them. So tell me in the comment section, please, if you've understood. Okay, so let us go to the next example. We did example 21, 22. Now we are going to example 23, which is conceptual. As I told you that this is famous questions in the manner of test 1 exam, and also the famous questions in manner of final exams or end of semester exam. So here we have example 23, and this is concept. With this concept, we say that refer DAT test 1 of 2014. It was question number 4. And also can refer special testing, which we used to call test 3. In special test, it was question number 1A, the second year. And also this question has been asked in the final exam, also a BAT final exam, okay, and supplementary exams. So that's why that I told you simply, this is famous question. So simply in many FEs, it has been asked in many FEs, in many supplementary exam. So the question state that determine, remember that I'm teaching you about continuity and discontinuity over the interval. Determine the discontinuity discontinuities, if any, of the following function. Of the following functions. The following function it's a composite function which comprises 5 functions. Comprises 5 functions. The first function is x cubic. And here the main is x less than or equal to -1. Then the next function is x squared minus 2. And this interval is -1 less than or equal to x less than or equal to or less than -1 less than x less than 1. 6 minus x. 6 minus x. This is 1 less than or equal to x less than 4. Then we have 6 over 7 minus x minus x. This is 4 less than x less than 7. And then the next function is 5x plus 2. Its domain is x greater than or equal to 7. So I won't delete these questions because we need it. And if you do this question, you will win 10 marks. So we did it. I told you how you can solve and find the discontinuities if there is n, maybe on left or right hand side for the composite function, which has two functions. In most cases of the continuity, we are dealing with composite function. Then I told you that how we can deal with a composite function that contains three functions. And right now, I'm teaching you how you can deal as a great mathematicians, how you can deal with a composite function that consists of 5 functions, just like this one. So it consists of 5 functions. The first function is x cubed. Its domain is x less than or equal to -1. The second function is x squared minus 2. So its domain is -1 less than x less than 1. Then the next function is 6 minus x. So its domain is 1 less than or equal to x less than 4. Then the next function is 6 over 7 minus x. Its domain, the next function, the first function, its domain is 4 less than x less than 7. Excuse me that my voice today is not okay, but don't worry, everything is well. Soon it will be recovering, and then you'll get surprised because my God has given me a beautiful sound. So it means that 6 over 7 minus x, then this is 4 less than x less than 7. Then you have 5x plus 2, and this is x greater than or equal to 7. All right. Okay, so if that's the case, ladies and gentlemen, we have again good news for you. So we can deal with these functions. Actually, we are going to follow so many steps, but we'll be just doing the repetitions of what we've been doing in the previous examples. Okay? So the first step, we have to choose the values of A. So the first step, we say that choose the values or identify the values of n. So we say that here we have to check this inequality, less than or equal, greater than or equal. These two inequalities that we have to deal with. Okay? So to deal with these inequalities, that's how we deal. So we have to identify them. The first thing, the first targeted value is the first value of A is x less than or equal to -1. So we say that A1, this is equal to -1. The second value, here we don't have any less than or equal or greater than or equal inequality sign. Here we do have that 1 less than or equal to x, and then less than or equal less than or equal to 4. So it means simply x is equal to 1. So the second value of A, which is A2, we tell us A2 it is 1. Then continue. You have to check to analyze. Then the next value here in the first function, in the domains of the first function don't have any exactly value of A. So we have against exactly value of A in the fifth function, which is x is equal to, which is A3 is equal to 7. Again, we are going to deal with because here we have 4 values of domains, 4 boundaries, -1, +1, 4, and 7. So there we've mentioned the -1, 1, and 7. So while here we have -1, 1, 4, and 7. So what is missing? 4. So 4 is not defined, so we'll deal with it later on. Let us deal with what you know. That's why I told you that these are conceptual questions. Once you are capable to solve these problems without even watching somewhere, without just watching the video, then I want to tell you, my dear student, you're in a very good position to overcome and even to solve so many questions in higher engineering and scientific mathematics. So let us go to the second step right now. Okay? Second step right now. We say that recall the general formula. General formula of what? Of continuity of the function T a print or over the interval, whatever the case. So this format is limit as x approaches to a of f of x. This is equal to f of a. Okay, that's the general formula that we have. So you have how many values of a? 3. So we are going to deal with one after the other. Okay, but this we can define further that limit as x approaches to a, the left hand side limit, a bar, this should be equal to the limit if it is continuous as x approaches to a positive of f of x, it should be equal to the value of the function when x is equal to a. Okay, so this we can call it equation 1. Okay, so you can call this one as equation 1. So you can go for the second steady state. So the steady state, we say that let us check. So check if the limit as x approaches to -1 of f of x is equal to f of -1. So let us check. So how are we going to check? We have to consider the left hand side. So it means there we are dealing with what? Here we are dealing with a is equal to, simply dealing with a is equal to a1 is equal to -1. So to find the limit, which is left hand side value of that equation 1, to find the limit now, we say that that's will be the first step. So the first step we say that let us find limit as x approaches to -1 bar, means the limits of left hand side. What is this? So it means that we have to come back to our composite function. This is x less than -1. So the corresponding function is x cubic. Here, this is x greater than -1. So this is the only suitable function in order to find the limit of the function on the left-hand side of -1, right? So then we say that this is what the limit as x approaches to -1 bar, okay? So our function here will be x cubic. So simply, because this is a cubic function, this will be -1 cubic, and the answer is equal to -1. Right? At the limits of left hand side. Then we go for the fifth step. The fifth step, we say that find what? Find limit as x approaches to -1 positive of 40 of f of x. Okay? So with this one again, we are dealing with, it means we have our interval is -1, so this is less than x less than -1. Here x is greater than what? -1. So if you examine our 5 functions of the composite function, this is the only interval which can help us to get the limits of the left hand side over the toward left hand side, right hand side of -1. Because here we say -1 is less than x, it means x is greater than -1. And this is the definitions. So to find that, we say that now the limit of our function, which will be the corresponding function, will be the limits of x squared minus 2, when x approaches to -1, approaches -1 positive, then this will make what? So this will make that -1. So the answer means that because the linear function is a quadratic function, so it will be -1 squared minus 2, and the answer is equal to 1 minus 2, which is -1. Right? Great. So it means that we have proved that the limit of left hand side means as x approaches -1 bar of 40 of the function, this is equal to the limit of right hand side as x approaches to -1 positive of f of x, and this is equal to -1. It's equal to what? -1. Okay. So that's the proof. So you have formed. So it means that now we've already formed limit as x approaches -1 of the function f of x. This is equal to what? -1. Okay, so you can consider that this is equation 2. Okay, do you enjoy the beauty of higher engineering and scientific mathematics? Please tell me in the comment section that if you enjoy, because I told you that I'm going to teach you in a very different way, a unique way, a new method. I'm going to implement so many new methods on teaching you about calculus that I've ever used it before. Are you ready to receive? Thank you for receiving, because I'm transmitting to you. Okay, so then we have now the limits of the functions when the value of a is -1. We have to find the value of a now. Means we have to consider the right hand side of the equation 1. So you go for the 6th step. The 6th step, we say that let us find what. Okay, so find what? Find f of a. So to find f of a, we have to remember that. What a are we dealing with? Find f of a1. Meaning that we have to find f of a1, which is equal to what? Which is equal to x, which is equal to -1. So again, we have to choose one function among the 5 functions. How are you going to choose? Where did you take x is equal to -1? This one. So because we took x is equal to -1, the domains that when x is equal to -1, then this is corresponding function. And this is the function that will help us to find f of -1. So it means that if f of -1 means we'll be using x cubic. So f of -1 is equal to -1 cubic, and the answer is equal to 1. Positive. So the next equation now. So the next equation we say that is this function equal to this function. Okay? So it means that suppose this is question 3. Okay? Question 3. So you say that the substitute. So the 7th step, we say that substitute equation 2 and the 3 into equation 1. So to substitute, on the left hand side we have -1, on the right hand side we have 1. Is -1 equal to +1? No. These are unequal values. So because they are unequal values, we say that the limit, it means that the function f of x is, f of -1 is equal to -1 cubic. It means this -1 times -1 times -1, the answer is -1. -1. So these are 2 equal values. So -1 is equal to -1. Since we say that now f of x from this fact, say f of x is continuous at x is equal to -1. F of x is equal to what? F of x is continuous at x is equal to -1. Interesting. Okay, so that's the situations that we have to expect it from. Okay, so again we say that we are dealing with another. We can deal with another function, with another value of a. So that was the 7th step. So 7th step, so I can deal with the 8th step. So with the 8th step, we say that The eighth step now, we have to deal with, we have to find limit. We have to deal with A is equal to what? So limits as x approaches to what? Next value approaches to 1 bar, the left hand side, means the limits of left hand side. So you have to find it of f(x). So it means that this one is when you have a2 is equal to positive 1. So again, we say that this is limit as x approaches to 1 negative of f(x). So what the corresponding function here? Wonderful. The corresponding function, it means that we say we are dealing with when x is less than positive 1. So when x is less than positive 1, this is the only functions which has a domain which is x less than positive 1. So our interest, our function of the interest, it is x squared minus what? Minus 2. So if you substitute there, then you find that we get 1 minus 2, which the answer is equal to negative 1. So remember the question asks us determine discontinuities if n, if n of the following functions. Okay, discontinuities. We may check the sentence. I think that something missing there grammatically. Determine the discontinuity if there is n. If there is n of the following functions. The following function. Okay, so again, we need to find what? We need to find the limits of right hand side. So limits as x approaches to 1, which is positive in this case, of the function now. Our function is f(x). So this is a 3, or this is still what we are dealing with, a 2, which is 1. Okay, so this one is equal to what? Limit as x approaches to positive 1. Positive, our functions now, it means we are finding the limit of the function when we approach 1 from the right hand side. So it means that at the point when x is greater than what? 1. So the point when x is greater than 1 is this one. So the corresponding function, it is 60 minus what? X. Right? It's 60 minus what? Minus x. So then we say that this is limit as x approaches to 1 positive. Okay? Of 40 of 60 minus x. Alright? So in this one, we say that this is 60 minus 1. So the answer is equal to 5. So from this 8th step, we cannot see that. Because you have to find. It means that you have to check. So check. If limit as x approaches to a bar of f(x) or a2 bar, okay, of f(x) is equal to limit as x approaches to a 2 bar of f(x). So we have what? We have negative 1. This is not equal to what? To positive 5. So these are not equal values. So because they are not equal values, then what can you notice about? You can notice that, oh, wow. So these two values are not equal. So the limit of the function does not exist. So if the limit of the function does not exist, I told you that that's equal to its essential discontinuities. There's no need even to find the value of f(n) because the limit of the function does not exist. All right? The limit of the function of the given function does not exist at x is equal to positive 1. Okay? So how do we conclude for this part? Okay, ladies and gentlemen, enjoy the beauty of higher engineering and scientific mathematics. If you have any question, don't hesitate to ask in the comment section, please. So we say that the limit of the function, the limit of the function f(x), okay, as x approaches to what? Positive 1 does not what? Exist. So therefore, the function f(x) is essential discontinuous. essential discontinuous at what? At x is equal to 1. So we have identified one discontinuity. Okay? No need for you just because the limit does not exist. Then at the end you conclude that this is discontinuous function at this point. That's all. Wonderful. So we go for the 9th step. The 9th step, we say that we have to deal with sorting with the third value of a, which is a3. And we took it from here, which is what? A3. Okay, mean that you find the limit of the function as x approaches to 7, which is a3 of f(x). Alright, we just keep doing. You can pause the video and then try that yourself. And then once you are done, you can play the video and check whether you are right or you're not right. Alright? Do that, please. Because mathematics really needs the hands-on work. Okay. Okay. Thank you. So, we have to find the limit of left-hand side first. As x approaches to 7 bar or 40 of f(x). So, f(x). So, you have to choose. So, it means that we have to find the limits of the function when x is less than 7. X is less than 7. So, the suitable functions which are satisfied at conditions which can give us the limits of left-hand side as we approach 7 from left-hand side is the fourth function. Because here we have x less than 7. So this fourth function is what? 6 over 7 minus x. Okay? So then we say that this is limit as x approaches to 7 bar of what of 6, 7 minus x. Okay? So if you substitute 7, then you get 60 over 7 minus 7, and this will make 60 over 0. So any number over 0 is undefined. Right? And remember that I told you, any functions which its limit is infinite, does give us infinite discontinuity function. So you see that now the application of the knowledge I told you in lecture 9. So we need to apply. So it means that you can quickly identify whether this function is continuous or discontinuous, and you are sure because you have the right information. Okay? So in this case, we find that limiting as x approaches 7 bar of 40 of 6 over 7 minus x, this is undefined. If we find again the limits of right-hand side is undefined, then we conclude that that is what it is what infinite discontinuity. I believe that you enjoy. The goodness of these questions, actually, it gives you so many important concepts. That's why that I used to prefer, once I solve this one, it is enough for students to go further and to deal with any questions of continuous and discontinuity. Okay, so then we have to find out limit as x approaches to 7 positive, right? Of what? So then we want x greater than 7. Where can we find from our given function? This one. Here we have x greater than 7. Okay, so our reference function is 5x plus what? 5x plus 2. Right? So if that's the case now, we say that, wow. So we say that here we have 5 times 7 plus 2. So the limiting as x approaches to 7 positive of 5x plus 2, this is equal to set 7 plus 2, set 5 plus 2, it's set 7. Okay? The answer is set 7. So from here again, we find that the limits of the function does not exist. Okay? So then we say that we go for the 10th step. Wonderful. Mathematics is beautiful. Okay, check it. Check if limit of the function as x approaches to 7 bar is equal to the limit of the function as x approaches to 7 positive of f of x. So then we have just to substitute our values. Here we found the answer is infinite, and also here we found is set 7. Is infinite equal to set 7? No. So it means that the limit of the function as x approaches to 7 of f of x does not exist